Hi students, welcome to my YouTube channel SADHIK Physics. So we already discussed kinetic theory of gases, no theory, all the different concepts, no. So I already discussed. If you did not watch, no, please watch that video. And in this video, so we'll discuss all different type of model questions, no, which can be asked in the kinetic theory of gases, no, right. So this video, before seeing this video, I suggest you compulsory watch kinetic theory of gases part 1 and part 2 theory which I made it, no, so that this chapter, no, this video you will understand very clearly. Okay. So if you really want to learn the physics, no, so please subscribe to my channel now. Okay. And also share my videos so that others also can learn physics very easily, right. So let us we'll start our video. You know, this basically kinetic theory of gases, no, we are going to deal with the gases now. Clear. So gases, we have the postulates onto this one, already detailedly explained, no. In this one, no, therefore Boyle's law, Charles law, pressure law, right, and kinetic theory of gases, no, in that RMS speed and so specific heats and ratio of their specific heats, no, right, and also internal energy, law of equipartition, this all concepts, no, and mean free path also we are going to deal these questions now, right. So really I selected different model questions now, so that you will get complete clarity on this chapter now, right. So let us start, right. Again I am telling now, so before seeing this video compulsory watch first video and second video of the kinetic theory of gases now, right. So let us start now. Now we will see first, let us, right, we will see the first question now. See, whenever you are solving the problems, no, first of all you should understand the question and you have to note down which are given parameters, no, and which one you need to calculate it. And in last step is therefore what will be the relations, no, the formulas, all this one, no, you need to get it out, that's all. If you keep these 3 points in the mind, no, you can solve any type of problems, no, very easily. So let us see one simple question, no. So first let us go for simple, then afterwards we will go for complicated, no. Calculate the pressure. He is asking pressure, we need to calculate the pressure, no. So given by number of moles, N is equals to 3 moles of an ideal gas equations you should know it, no, vessel. So kept in a volume, therefore volume is given as 6 liter always utilize in SA system, no. I already told you, therefore here 1 liter is equals to 10 to the power of minus 3 meter cube, volume is meter cube. So into 10 to the power of minus 3, so therefore here meter cube, this is your volume. And temperature, see I already told temperature while calculating the gases, no, therefore the temperature should be always in kelvins only. So it is given as 27 degrees centigrade, no. So therefore 27 plus 273, so therefore 300 Kelvin. Then what will be the relation now? Ideal gas equation you can write it now, PV is equals to nRT. So that implies pressure is equals to therefore nRT by therefore V. N is nothing but 3. So R value is nothing but 8.3. So value therefore 300 divided by 6 into 10 to the power of minus 3. Clear? So therefore here what you can write it now? Then you can get it as, so 3 therefore 3 2s, so therefore 2 4.15. so therefore here you can write it now, therefore 4.15 into 3, so this 2 zeros taken now 10 to the power of 5. So this is 15134 point, therefore 12 into 10 to the power of 5. So Pascal, this is here the pressure which is exerted by this gas. Very simple question, no? Clear, right? So that you can understand very clearly. So coming topics now, learn these simple questions also, no problem. So then we'll go for slightly another one more question now. Let us see here one more question now. Slide. See if this question is not visible, no, please concentrate on my words, no, so that you can understand very clearly. So here what is given now? A vessel is there. So it is given volume. There is a one vessel is there. So here there is a vessel is there now. This is vessel. Clear? So there is a vessel is there. So what is this volume now? Volume is given as a vessel of volume 8.3 into 10 the power of minus 3 meter cube. SI unit only. Contains an ideal gas. There is a gas is there inside this one now. At what temperature now? Temperature is about 27 degrees centigrade. Means 300 Kelvin immediately. The pressure is also given now. Therefore, the pressure now. Pressure is given as 200 kilopascal means 2 into 10 the power of 5 pascal. Clear? All are given SI units, no need to change anything. So now the gas is allowed to leak. Therefore, some gases, what happened now? It went off. There is a, so leakage is taken place now. That means some gas is left out. We don't know how much gas is now. Is allowed to leak till the pressure falls. Now the new pressure. Okay. Initial volume V1, initial temperature T1, initial pressure P1. Now finally what happened now? There is a, here the pressure P2 becomes like 100 kilopascal means 10 to the power of 5 pascal, and the temperature is increased to, therefore temperature T2 is 327 degrees centigrade now. So this is heated now. So now what happened now? Therefore apply 273 means nearly 600 Kelvin now. 273 added now 600. And what will be the amount of gas in moles is leaked out? Can you tell me if initially how much volume is there? Finally also the volume it will be the same only. Why? Because here the volume of the gas, no, it will occupy the volume of the container, no. Therefore V2 is also nothing but 8.3 into 10 to the power of minus 3 meter cube. Now we have to calculate how much amount of mass of the gas which is leaked, right? How many number of moles, okay? Like that you can calculate it now. You understand? So simple thing, no. Initially what we have to calculate how many number of moles is there, no. Finally how many number of moles of the gas is present inside this one, no. Then initially some amount of moles will be there, finally some value will be there, that's difference, no. That much amount of mass of the gas which is leaked out of this. Clear? So that means number of moles is N1 minus N2. So now what we have to calculate, what will be the number of moles it is there, no. Number of moles it is, finally it is there. Clear? So very simple. Therefore I think you understood, no. Therefore how to calculate it now? First situation, no. First one, no. First situation, no. So number of moles, what you can write it now? Number of moles is nothing but PV by RT. Yes, no? So therefore P1 V1 by R1 RT. So P is how much now? 2 into 10 to the power of 5. Right? So we can rewrite it as, therefore here temperature is also changing, no. Okay. We'll write it here, no. Okay. So number of moles. Okay. If you want to calculate separately, calculate, no problem, no. So here number of moles of the gas which is leaked, no. Therefore you can write down P1 V1 by R into T1, therefore minus P2 V2 by R into T2. Clear? So in this volume both of they are same, no. R is also same. Therefore V by R taken out because V and R is same, no. P1 by T1 minus P2 by T2. Clear? So V is how much now? 8.3 into 10 to the power of minus 3. So this also 8.3. So therefore P1 is how much now? 2 into 10 to the power of 5 by, therefore 300 minus. So here 10 to the power of 5 by 600. Clear? So I can make denominator as 600 is same, no. I can multiply with 2. So therefore here it will become 4 and it will be the 600. So this is 8.3 cancel here, no. 10 to the power of minus 3. I can multiply with 2. I can divide with 2. So total is 600. 2 to the 4 minus 1 3. So 3 into 10 to the power of 5 by 600. Clear? So therefore here if I take these two zeros and take it top, no, 10 to the power of minus 5. So this plus 5 get cancelled, 1 by 2. So therefore here it will be remains like a 1 by 2. 1 by 2 moles of gas, no, which was leaked it out. Clear? Half mole of the gas, no, which is leakage was taken place, no. I think you understood, no. So therefore always see a number of moles, no, it will be you have to calculate it, no, for leakage of this gas. So, I think you got the clarity, no? Now, we will go for one more question, no? Now, right. So, at a constant pressure, now we will see at constant pressure is constant. So, pressure is constant. Pressure constant means you should know that it is nothing but a Charles law, right. So, N2 occupies the volume of 30 liters, N2 nitrogen gas occupies a volume, therefore, V1 is equals to 30 liter. So, at temperature T1 300 Kelvin. Now, find the volume, therefore, we have to calculate V2. So, temperature T2 is given how much now? 427 degrees centigrade plus 273 added, no? Plus 273, how much now? This is 700 Kelvin, right. Here if pressure is constant, no, so you can rewrite it as, therefore, PV is equals to nRT. So, pressure is constant, no, volume is directly proportional to the temperature, no. Therefore, V1 by T1 is equals to V2 by T2, that implies V by T is constant. Clear? So, therefore, here liters, here also we will write down in terms of liters only, because this ratio only we want to calculate, no. Therefore, 30 divided by 300, it will be equal to V2 by 700. So, this you can get cancelled out, no, 1 by 10, therefore, this 0 and this 0 also cancel. So, V2 it will be equal to 70 liters. Clear? This is a simple question, no? Right. So, meanwhile, if you solve some simple questions, no, therefore, difficulty level if you increase also, you will not face any problem, no. Now, let us go for another one more problem, no. Right. Now, so let us see 20 liters of CH4 exert the pressure of 80 bar, right, at a constant temperature. So, temperature is constant in this one. Temperature is constant means immediately you should get into your mind that should be Boyle's law, right, isothermal process also you can take it now. So, what is given now? V1 is a volume is given how much now? 20 liters, right. So, pressure is given now, P1 is nothing but 80 bar. Clear? So, find the pressure, you need to calculate the pressure. If it is volume occupies, no, V2 is equals to 40 liter. Clear? So, temperature constant means, so PV is equals to nRT, PV is equals to constant. That implies P1 V1 is equals to P2 V2. Clear? Now, substitute it now. Therefore, here, so 20 into 80 into 20, 80 into 20 is equals to PT into P2 into 40. So, this side liter also. Answer will get in terms of bar, no. So, therefore, P2, therefore, you can write it as like a 2. So, 40 bar, right. So, you know how to convert it, no. So, 1 bar is equals to in terms of pascals, no. In our video, I already discussed. Clear? Right. Now, let us go for another question, no? Right. Right. So, this graphs relations, no, right. So, he is asking what will be the T1 and T2. Clear? So, here pressure PV, so it is telling that it is constant, no. Clear? So, here by seeing this, no, PV it is saying constant, no, constant, but here PV is equals to nRT. So, that means whose PV value, therefore, PV, so if you take it now, as temperature is larger, PV value also increases onto this. That means, so in this one, no, PV values is more, when it is more, no, when T1 temperature is more, so therefore, PV value is larger. When temperature T2 is there, PV value is lesser, no. So, therefore, PV value is more at T1 temperature, no. Therefore, directly proportional to T. So, therefore, here you can write down T1 should be greater than T2. This should be your answer. Clear? Right? So, sometimes isotherm questions also they will ask, no. Suppose here P and V relation is there, no. This is one graph, this is one graph, no. T1, T2. Recent JEE mains also this type of questions is given. then you can tell that which is having more temperature means what will be the temperature region now. As you are going, temperature is increases, the pressure of this level also increases. Therefore, T2 will be greater than T1 in this question. Clear? But for this question, this is your answer. Clear? So, go through, understand the graphs, no? Then you can get the clarity onto this. Clear? Now, let us go for one more question. No? Yeah. Okay. Now, what is given now? P and inversely proportional to the T graph. Therefore, PV is equals to nRT graph. It is given PV is equals to nRT. So, I will take it here now. P by T is equals to nR by V. So, that means I can rewrite it as now P P into 1 by T is equals to nR by V. Here you got it, no? P and into 1 by T, so it will be equal to nR by V. Like exactly we just now we discussed now, PV is equals to nRT. So if temperature is constant now, therefore P is inversely proportional to the volume. Therefore, you like this. Exactly the graph is also given in the same way. Clear? So now what you have to do now, therefore here we need to calculate which one is greater, V1 or V2 no. Therefore you see here no. So here it is T1, T2. Therefore here in this one now, in this area, therefore here T2 is larger means this value is larger means T1, T2 should be smaller, I mean larger now. Here this value is larger means this also will be larger now. That's why we written as T2 is greater than T1 now. Similarly, here you can see it now, but it is here inversely proportional onto this. That means in this part now, therefore this area, this is smaller here no, this region is smaller. That means this 2 will be larger onto this. Clear? Because it is inversely proportional now. Therefore, here this in this one now smaller means this should be larger. So in this area is larger means this value is small. This value will be smaller now. Therefore, V1 will be less than therefore V2. So in this way you can get the relation. Clear? Okay. So now let us go for one more question. No? Right. Clear? Now at particular temperature, N2 exert the pressure of, particular temperature, we don't know what is the temperature, N2 exert the pressure. Therefore, nitrogen gas is given now, pressure is given how much now? 60 bar. And O2 exert the pressure, therefore O2 exert the pressure, therefore it will be equal to 25 bar on the walls of a closed wall. Okay, find the pressure exerted by them. So if they are mixed together onto this. So here these are the two different gases, no? Therefore O2 gas, no? So they are contained in a certain vessel onto this one, no? Clear? So this also it will be contained in the same vessel, no? So the pressure exerted by this one, no? Pressure exerted by this one, no? Again they are mixed in the same vessel, So that means volume is same, volume is constant. Clear? So therefore we can rewrite it as, and also temperature change also is not there, no? So number of moles we can rewrite it as number of moles is equals to N1 plus N2. So you can write down therefore pressure due to of this combination into same volume by RT. So here it you can write as pressure V1 by V and RT plus pressure P2 V by RT. Clear? So volume is same in this all this situation, no? Therefore temperature is also not changing, no? P by RT, I mean V by RT taken common, cancel, no? So P is equals to P1 plus P2. This is nothing but a Dalton's law. So therefore here you can just add this one, no? How much you will get it now? So 60 plus 25, therefore it will be the 85 bar will be the pressure exerted by the gas. Clear? So if any time there is a mixture is there, no? So please go through this concept, no? So number of moles. Here compulsory one more thing is there should not be any chemical reaction should take place. No? That is, so go through this concept, no, so that you can understand very clearly. No? Now we will go for one more question. No? Let us see. Right. At a particular temperature and pressure, 4 moles of N2 occupies a volume of 30 liters. Find the volume occupied by 16 moles of O2 at the same temperature and pressure. Now. So what is given now? Therefore, here N2, right? So how many moles are there now? Number of moles of this are now 4 moles. 4 moles. So N2 occupies a volume of therefore 30 liters. No, 30 liters. Then find the volume occupied by the O2. Therefore, so oxygen volume occupied by this one. No. So therefore, number of moles are how many? 16 moles are there now. At same temperature, same pressure. No, same temperature, same pressure. No. Clear? So here what we can write, you know, PV is equals to nRT. Therefore, ideal gas equation onto this, right? So here PV is equals to nRT. So in this one now R N and V only it is there now. So therefore V by N is equals to nRT by nRT by P. Therefore this is both the things are, sorry, not N, sorry, here no. So here N is taken here no, RT by P, both of this and it is constant. Clear? So therefore V by N is constant, V1 by N1 is equals to V2 by N2. Clear? So now here V1, so V1 is nothing but how much now? Therefore here 30 divided by 4 moles. Here it is nothing but a V2 by the oxygen. This is V2, this is V1, N1, N2. N2 is nothing but a 16. 4 1 the 4 4 the V2 is equals to 4 into therefore 120 liters. This is the volume occupied by the oxygen at the same temperature and pressure. Clear? Very important concept now. Now let us see one more question now. So this type of question now frequently asked in the examination now, because the students are going to get confused in this one now. See, he gave the RMS velocity of the gas now. See, RMS velocity of the gas. The RMS velocity of the gas molecule of the amount of the gas at this pressure is 100 meters per second. How much it will be now? It is given as 100 meters per second. Right? So at what temperature it is given now? Temperature is 27 degrees centigrade now. Pressure is also given now. How much now? 10 to the power of 5 Pascal. Therefore it is nothing but 300 Kelvin. Now this is initial temperature, initial pressure now. So what will be the RMS speed is asking now, when the temperature T2 is 527 degrees centigrade means, so 273 added, no, 2 means, so 800 Kelvin. So pressure P2 is nothing but a 2.5 into 10 to the power of 5 Pascal now. So therefore most of the students know here the pressure is given, how to do it, no, they will use different formulas. No, one very important point is that RMS speed depends only on the temperature. It is an independent of the pressure. Clear? So therefore here this pressure is given is only to confuse you, know. So RMS speed is directly proportional to root temperature. Right? So these pressures are given only to confuse you only. Right? So then we can find it now. Therefore RMS speed of these two we can write it as V1, it will be equal to root of T2 by T1, root of T2 we want T2 is nothing but 800, so divided by T1 is nothing but 100, so get cancelled out, no. So that implies V2 is equals to root 8 into V1. So root 8, therefore V2 we can write down root 8 means 2 root 2 into 100. So therefore 200 root 2 meters per second. This is here the speed of the gas molecule. Actually, we did one small mistake now, that is here it is not 100, it is 300. So, therefore, here root 8 by 3. So, therefore, here RMS speed it will be so root 8 by 3 into 100 meters per second. This is your RMS speed now. Here I substituted as a 100 no, right, that you change it now. Okay. Now we will go for next question now. Let us see here, okay, RMS speed. What is the RMS speed formula actually? So, RMS speed, it is nothing but a root of 3 RT by TCM. Clear? Now, therefore, here RMS speed not only depends upon the temperature, it is also depends upon the mass of the gas molecule now, gram molecular weight onto this. Clear? So, therefore, here what you can write it now? Here it is told that it is the same temperature no. So, therefore, here RMS speed is at temperature is also same, R is also same, it is inversely proportional to root of this M. Therefore, of O2 by H2 it can be written as, it is inversely proportional no, therefore mass of H2 by mass of O2. So, this hydrogen gas no, therefore it is 2. So, oxygen gas no, therefore it will be 32. So, therefore here how much now, it will be 16 no. So, here it will be equal to 1 by 4. Clear? So, VO2 can be written as VH2 divided by 4. So, VH2 is how much now? 8 into 10 to the power of 3 meters per second divided by 4. 4 it is 2. 2 into 10 to the power of 3 meters per second now. This is your answer. Clear? Right? Now we will go for another question. Let us see. Let us see this question now. Here at constant temperature is not changing now. Therefore, if the pressure of the gas is changed, therefore here the speed of the gas molecules no is independent of pressure. Why? Therefore, pressure by density of the gas is always constant. So, here what he is told now? He told that pressure of the gas is tripled. Therefore, pressure is changing onto this one now. Therefore, there is no change in the speed. Most probable gas no, most probable speed no, and RMS speed no. Therefore, does not able to change. There is no change in the. There is no change. Therefore, fractional change in the speed. So, it will be equal to 0. Yes, and clear? So, there is no fractional change of the most probable or RMS speed now. Why? Because so the speeds are independent of your pressure. Clear? Now, let us see one more question now. Right. So, calculate the minimum temperature at which N2 molecules will escape from the earth. See, this is why our atmosphere is there no, on the earth surface no. So, this also is one of your important conclusion now, right. Let us see, escape speed. Escape speed is how much now? What is the escape speed now? Escape speed is this one now. So, it should be equal to 11.2 kilometers per second. Yes, so that means into 3 meters per second. Therefore, here 11,200 meters per second. This should be the compulsory RMS speed now. Therefore, the gas molecule should attain this one now. Then, what should be the temperature? Temperature is how much now? We want to calculate no. RMS speed, it will be equal to 3 RT by, therefore, it is M. Clear? So, whole square, therefore, T is equals to whole square no. So, RMS speed, therefore, M by 3R into V RMS whole square. So, gram molecular weight of this one no. Therefore, here it will be N2 molecule no. Therefore, 7, 14, 28 divided by 3 into 8.3 into, so 11 into, right. So slightly calculation was lengthy onto this. I will use a calculator to solve this one. No? Right, nearly if you solve this one, no, you will get it as nearly 14 into 10 to the power of 4, 14 into 10 to the power of 4 kelvins. That means 1,40,000 kelvins. That much temperature is required, no, so that our N2 molecule from our earth surface, no, it is going to escape it, no. So therefore this much temperature is not possible, no. So therefore N2 will not be able to escape. That's why we have the atmosphere on the earth surface, no. Is it clear? Right. So now we'll go for one more question, no. Right. Now we'll write it now. Let us see. Okay. Find the rotational energy. See, not internal energy. Internal energy, you know it, the formula. Therefore, U is equals to, so F by 2 RT or NKT, nRT. So therefore, F by 2 nRT or U is equals to F by 2 NKT. Clear? So these are the energy formulas, no, we already discussed. F is nothing but a degrees of freedom, no. Clear? So in the degrees of freedom, we already discussed translational degrees of freedom, no, rotational degrees of freedom, no, like that. In this he is asking what rotational energy, rotational energy. Therefore you have to take it as rotational degrees of freedom of 4 moles. How many moles are there? No, N is equals to 4 moles of N2. N2 means diatomic. Yes or no? Therefore diatomic, therefore N2 is diatomic. So you know that, therefore there is a translational degrees of freedom is how much? No, 3. Rotational degrees of freedom is 2. Clear? Be careful now. Rotational degrees of freedom. Why? So N2 molecule is there now. So here how many ways it can be rotated? No. Therefore here 2 ways. No. It can be rotated like this. So therefore it can be rotated like this. No. Right? Along this one. No. Therefore these 2 molecules are lying in the same. No. There is no rotational. No. Degrees of freedom. Rotational degrees of freedom is 2. But total energy is how much? No. Translational plus rotational means 5. Clear? But he did not ask. So he did not ask fully. Therefore total it didn't ask. No. He asked only rotational. No. So it will be equal to rotational degrees of freedom is 2 by 2 into R. N is nothing but 4. Number of moles are 4. R is nothing but 8.3. At temperature is 127 degrees centigrade means 400 Kelvin. Clear? Clear? So therefore here what you can write in, no, this will get cancelled out, no. So this is here 1600, no. Therefore here 1600 into 8.3. Clear? So 160 into 83. How much it will be now? So we can rewrite it as 13302 joules. Clear? So in this way, suppose the same question is asked now, what will be the total energy? So is associated with this one means you have to take it as total translational plus rotational. Clear? So be careful with which one they are asking now. Clear? So like this, if you really understand the question now, then you will see this one now. Clear? Now let us see. Right. At 127 degrees centigrade temperature now, the total energy of the ideal gas is E1. Okay. Then if the temperature is increased to, then total energy. See. So here total energy is directly proportional to the absolute temperature now. Clear? So therefore here it will be, so U it is given as at 27. So U2 by U1 is equals to T2 by therefore T1. So this U2 we want to calculate. U1 is given as E1. So therefore temperature is given as how much? No, T2 527. 527 plus 273 by 127 plus 273. Clear? So this is 7, 800 divided by, this is nothing but a 400. This is nothing but a 2. So therefore U2 is equals to 2E1 will be your energy. Increased 2. Clear? Right? Increased by something like that, if you say no, then it will be the different answer. Clear? Now we will go for another question. Right. Find the ratio of total energy of 4 moles of monoatomic gas at 300 Kelvin, 6 moles of diatomic gas at 280 Kelvin. Now, therefore, here ratio of total energy, that means here we can take it as total energy. Total energy, what is the formula here? No? So here F by 2 nRT, temperature it is given, no? Moles is given. No? So therefore here F and N is there, R and okay, temperature is also same. So number of moles is also different, no? R, F. Why? Because monoatomic, diatomic. Clear? So therefore U2 by U1 is equals to directly proportional to this one, no? F2 by F1 into N2 by N1 into T2 by T1. Clear? So here you know that monoatomic now. Monoatomic degrees of freedom is 3. Suppose here we are taking as one as monoatomic, second one as diatomic. Clear? So be careful now. So therefore here diatomic total is nothing but a 5 degrees of freedom. No, 5. We are not considering vibrational one. No. So monoatomic is nothing but a 3. Number of this one is 6 moles. This is 4 moles into T2 is 280 Kelvin, no, by 300 Kelvin. No. Clear? So this is now, therefore here 3 1s are 3 2s are 2 1s are 2s are 2 140. Clear? So therefore here you can take it as this one. No. So here 5 4s are 20, 2 5 70 divided by, therefore here 30. So take and cancel here, no. Therefore 7 by 3 will be your answer. Clear? One more question. Here so what is given now? 7 moles of triatomic gas at 400 Kelvin. What is the fraction of total energy is a rotational energy. So what is the fraction of total energy is a rotational energy, right? So here total rotational energy, there is a 2 rotationals will be there. So triatomic, it did not specify that no, it is linear or non-linear. No, we will take 2 rotational and 3 translational. No. Therefore here total energy due to rotational by total energy due to total one onto this. Rotational kinetic energy is how much now? Degrees of freedom is 2 by 2. Therefore nRT divided by total one, no? Rotational plus translational 5 by 2 nRT. Clear? So this will get cancelled now. Therefore 2 by 5 will be your answer. Clear? Simple one, no? Now let us go for one more question. No? Right. 3 moles of monoatomic gas is heated at constant pressure. Pressure is constant. From 27 degrees centigrade to 227 degrees centigrade. Okay. Amount of heat energy required. Heat energy at constant. Therefore, specific it's no. Heat energy supplied at constant pressure is nothing but NCP into delta T. Delta theta, suppose. Clear? So, how many moles are there now? Cp. Cp means how much now? Therefore, here Cp, what is the formula? Cp minus Cv is equals to R. Therefore, here Cp by Cv, gamma is equals to Cp by gamma is equals to 1 plus 2 by F is equals to Cp by Cv. These two compulsory you need to remember. Cp is equals to, okay, Cv is equals to, so Cp by gamma, therefore Cp by gamma, therefore what you can write it now, Cp minus Cv is equals to R. So therefore here Cp is nothing but a gamma minus 1 by gamma is equals to R. So Cp is equals to gamma into R by gamma minus 1. This is your Cp. Clear? So monoatomic means degrees of freedom is 3. Therefore 1 plus 2 by 3, that means 5 by 3 will be your gamma. Clear? So you can rewrite it as how much now? N, number of moles are 3. So Cp value is how much now? Therefore gamma into R by gamma minus 1. So therefore here, right, we can rewrite this formula here now, not required. Therefore N into, so gamma into R by gamma minus 1 into delta theta. Clear? So 3 moles into gamma value is how much now? 5 by 3 into R by 5 by 3 minus 1 means 2 by 3 into delta theta is nothing but a, see, change in temperature in Celsius, change in temperature in Kelvin, both are same. 227 minus 27 means is nothing but a 200 Kelvin, it will be the same. So therefore this will get cancelled out now. So therefore here what you can write it now, this is your 100, so 15, therefore 1500 R joules. Clear? So be careful now, these are nothing but a specific heats no, these type of concepts no, so frequently asked in the examination, check it now. Clear? Right, now let us go for one more question now. Suppose right, so now here 4 moles of diatomic gas is heated at constant volume. So constant volume, by giving this much amount of heat, calculate the change in temperature of the gas. So delta Q in terms of V, it will be equal to N Cv into delta theta. So he is asking what will be the change in temperature now, delta theta. So he gave this value, so simple. So substitute 300 R is equals to Cv. Cv is nothing but a, you can write down R by gamma minus 1. Clear? Right? So Cp minus Cv, right? Cp is equals to, okay. Therefore here now gamma is equals to 1 plus 2 by F. What is given now? This is your diatomic gas. This is your diatomic gas no. So diatomic gas means degrees of freedom is 5, 2 by 5, therefore 7 by 5. Clear? So we can write it as 4 moles. It is given as 4 moles into Cv value is how much now? R by, therefore gamma minus 1. Gamma minus 1 means, so this 7 by 5 minus 1 means 2 by 5 into 5 into delta theta. Clear? Therefore here it is 2. So this is 10. These 2, it is 0. Therefore this also R. Delta theta is nothing but a 30 Kelvin. Change in one. Change in Celsius also it will be the same. Clear? Now let us go for one more question. No? Right. So 4 moles of monoatomic gas, monoatomic, okay. So 2 moles of diatomic gas are mixed. So then find the value of the gamma of the mixture. So therefore gamma of the mixture I already discussed in a mixture no. Therefore here what you can write it no. So gamma of the mixture, therefore, so gamma value is nothing but Cp by Cv. Therefore N1 into Cp1 plus N2 into Cp2 by N1 Cv1 plus N2 Cv1. This is your, okay. So this is a value, therefore you can solve it now. How to solve it now? First of all you have to calculate Cp1 and Cp2, right? So Cp1 for 1, for 2. So 1 is what? Mono, and 2 is what? Diatomic. Clear? So monoatomic we already studied no. Therefore Cp is nothing but how much now? So Cp value is nothing but a, so gamma into R by gamma minus 1 no. So therefore here, okay, in terms of this one. So here for mono, gamma value is how much? No, for mono gamma value is nothing but a Cp by gamma value 1 plus 2 by f. No, so 1 plus 2 by 3, so that is nothing but a 5 by 3. For diatomic, no, 1 plus 2 by f, 2 by 5, so 7 by 5. Clear? Cp value you know it, no, gamma into r by gamma minus 1. Cv value already know it, no, r by gamma minus 1. Then for monoatomic value substitute it now. What you will get it now? Cp1 for monoatomic, no. So gamma value is how much? No, mono 5 by 3. So 5 by 3 r by 5 by 3 minus 1 means 2 by 3. Get cancel out, no. Okay, we'll write it now clearly. Okay, so Cp1 it will be equal to therefore here how much? No, 5 by 3 for mono, 5 by 3, 5 r by 3 into 5 by 3 minus 1 means, so 2 by 3 get cancel out, no, therefore 5 r by 2. So this is a value. Clear? Cv1 for monoatomic, no, r by gamma minus 1, therefore here 5 by 3 minus 1 means 3 by 3 r by 2. Clear? So this is your Cp1 and Cv1 for mono. Similarly Cp2, these all are the values, no, you need to be remember now. How you will remember? Frequently if you are doing the questions, no, you will be able to remember these values, no. For your convenience, no, I am trying to explain it, no. So next time onwards we will use directly these values. For monoatomic Cp value is nothing but a 5r by 2, so Cv value is 3r by 2 for monoatomic. For diatomic you can write it, no, so 7 by 5, 7 by 5 r into 7 by 5 minus 1 means 2 by 5 get cancel out, no, 7 r by 2, this is your Cp2. So Cv2 how much it will be now, right, r by, therefore this one, no, so 7 by 5 minus 1 means 2, therefore 5 r by 2. These all are the values you need to remember for Cp1, Cp2. Even in thermodynamics, no, I will use these values, no. Clear? For monoatomic, so Cp1 is nothing but 5r by 2, Cv1 is 3r by 2. So for diatomic, no, Cp1 is nothing but 7r by 2, so Cv2 is nothing but 5r by 2. That's all. Remember this one, no? Clear? So for 1 is monoatomic, 4 moles, 4 into for monoatomic, therefore 5r by 2 plus N2 is diatomic, no, 2 into Cp2, therefore 7r by 2 divided by N1 is nothing but a 4 into Cv1 is nothing but a 3r by 2 plus N2 is nothing but a 2 into therefore 5r by 2. Clear? So what you will get it now, these 2 cancel now, therefore it is also 2. So this is 2, these 2 can cancel out now. So here it is how much now, this is 5 2s are 10 plus 7, therefore 17r divided by, this is 6 plus 5, so 11r. (17 by 11) will be your gamma of the mixture. Right? We'll see this question now. Right? Two gases now kept in the two identical vessels. Identical vessels are same now, of 30 liters at same temperature of 300 now, and same pressure of 20 atmosphere now, are mixed in the vessel is having the same volume. So find the resulting pressure now. I already discussed the Daltons now. So in this mixture now you have to and always remember that number of moles it will be equal to N1 plus N2. That's all. So here pressure, equivalent volume by R into temperature. At what temperature they are mixing now? Therefore P1 V1 by R into T1 plus P2 V2 by R into T2. Simple question it is given now. kept two identical vessels, no, vessel same, no, same volume, no, this V same. So therefore here same vessel, same temperature, no, this temperature is same, no, same pressure, no, therefore this pressure and this pressure is same, no. So therefore what you can write it now, pressure it will be equal to this V by RT taken common, no, therefore cancel it, no, P and P2 20 plus 20, therefore 40 ATM. So when they are mixing in the same volume, no, therefore the pressure will become like a 40. Clear? Now we'll see one more question. No? Right. A vessel containing the mixture of methane gas, no, oxygen gas. Okay, methane and oxygen gas is then, no, 24 grams, 8 grams of methane mass 24 grams of oxygen. A temperature is 300. Pressure is given now. Density of the mixture. No? Clear? So therefore here density you can rewrite it as formula, no, therefore PV is equals to nRT. So therefore PV, right. So n of different is there, no, n of the mixture. So n number of moles of the mixture, no, it will be, can be written as, so n1 plus n2. Clear? So number of moles of methane, so this is here 8 grams. What is the methane? No, CH4. Clear? CH4 means carbon is 12 plus 4 16, therefore 16, no, plus 24 grams divided by also 16. No? Clear? How much it will be now? So 8, therefore here it will be 32 divided by 16, therefore it is 2. So will be your mixture. Clear? So n mixture, n of the mixture, no. So these are mixed at certain temperature it is given, no, therefore pressure is given. Therefore what is the volume it is occupied, we don't know here, no. So we can substitute here, no, therefore pressure is how much, no, 2 atmospheric pressure. 2 atmospheric pressure means 2 into 1.01 into 10 to the power of 5, it is volume, therefore it is 2 into 8.3 into temperature is 300. Therefore volume it will be equal to these 2 and these 2 get cancelled out, no. So therefore here 8.3 into 300 divided by 1.01 into 10 to the power of 5. Clear? So therefore here you can take it here, no, therefore 83 into 30, so taken top, no, into 10 to the power of minus 5 by 1.01. Okay, so let us solve this one, no, therefore here 83 into 3 is equals to divided by 1.01. So therefore here it is 246.5, this gone, no, 10 to the power of minus 4 meter cube. This is your volume now. Clear? So now we want to calculate density of the mixture. No, density is equals to mass by volume. Clear? So mass are given in grams, no, therefore this will write down in terms of centimeter cube, no. So centimeter cube means here, you know, therefore 1 meter cube is equals to 10 to the power of minus 6 centimeter cube. Clear? So 10 to the power of 6, no, centimeter cube. Clear? So 6, no, you can rewrite it as, therefore here 246.5, if you write it as 10 to the power of 6 means into 10 to the power of 2 centimeter cube. Clear? So how much mass it is given now? 8 plus 24 grams, no. How many grams, no? Therefore total 32 grams divided by, therefore here 24650. Clear? Centimeter cube. So 32 divided by 24650, so you will get it as 0.00129 gram per centimeter cube will be the density. Clear? So gram per centimeter cube. Clear? So this will be a density of the given mixture. Right? So I think you understood, no? Now we'll go for one more question. An oxygen molecule is traveling at in the air, no? At temperature it is given. Temperature how much, no? Therefore 300 Kelvin, no? Pressure is given 1 atm, means 1.01 into 10 to the power of 5 Pascal. Diameter is given, no? Diameter D 1.2 into 10 to the power of minus 10 meters. He is asking mean free path. What is the mean free path formula? We know it, no? Mean free path, no? 1 by root 2 into pi into n into d square. Clear? So therefore here d square is nothing but a diameter, n is nothing but a number of molecules per unit volume. Actually n is nothing but what? Number of molecules per unit volume. So what you can write it now? Number of molecules, no? You know that PV is equals to NKT. So therefore n by V, therefore you can write it as n by V. So can be written as P by KT. So therefore here P by KT. Now we can substitute it now. Therefore here 1 by root 2 into pi into n is nothing but a P by KT, P, therefore KT by d square. Clear? Now everything is given, no? Temperature is given 300, no? Pressure is also given, no? Diameter is given, K value already know it, no? Substitute it, you can get your answer. K is nothing but a Boltzmann constant. So 1.38 into 10 to the power of minus 23 into temperature is 300 divided by root 2 into pi 22 by 7, that means 3.14 into pressure is 1.01 into 10 to the power of 5 Pascal into diameter square is 1.2 into 1.2 into 10 to the power of minus 20. I think therefore these are the values, no? You need to solve it, okay? Therefore solving I am leaving for you. So you try to calculate it, no? Then you will see the value, okay? I will take down this value, no? Right? I already calculated, so therefore I will get it as nearly 0.63 into 10 to the power of minus 6 meters. That means this much distance it is going to travel before undergoing any successive collisions. Now, clear? Right? So till here, I think therefore the time is very lengthy onto this. No? Therefore, we will do like this as 2 videos. No? Therefore, part 1, right? We can continue for these numericals. No? And part 2 we will do as a one more video because it is too much lengthy, it is taken place. No? So we will do remaining continuation questions. No? Remaining other 25-30 questions are there. So we will do in the next part. Okay. Thank you for watching. Please subscribe to my channel.